Okay, I'm going to do, at the end of the last sort of mini lecture, I was poised to do another example, at which point my pen, my iPad pen started acting up and I couldn't figure out what was wrong with it. I've now figured out what was wrong with it, so I'm going to do this problem in a separate video. So it's just going to be a video with just one problem. And again, this is an example that is certainly more difficult than anything that I would expect you to do. But it's fun to do, it's interesting, and it might be illuminating. It might actually, give you some insight into how to do simpler problems. So here's the sentence that we're going to be looking at. There exists, already messed up. There exists an x for all y, rxy and not ryx, right? X R's y, but y doesn't R him back. Horseshoe, not rxx, if and only if not ryy. Okay, so here's our task. We want to show that this is not quantificationally true. In other words, we want to give a falsifying, construct an interpretation that makes it false, thereby showing that it's not quantificationally true. Well, it's kind of a hard sentence to parse. There is an x such that for all y, x R's y, but y doesn't R it back. If that's the case, then not Rxx, if and only if not Ryy. Well, I don't know about you, but I find that really difficult to parse. One of the strategies that I mentioned in an earlier lecture is that if you're finding it difficult to construct an interpretation that makes a sentence false, you can negate it and then find an interpretation that makes the negation true. So let's try that. Let's negate the sentence. Well, how do you negate a sentence? You put a negation sign in front of it, which of course is not going to make it any easier to understand, but we're going to manipulate it. We're going to get it into a form that we can parse much more easily. Okay. Well, obviously, sticking a negation sign in front of a complicated sentence doesn't suddenly make it understandable. So what we're going to do is we're going to manipulate things and get it into a form that we can understand better. So what we're going to do is we're going to take this negation sign, right? So we're going to negate the sentence and verify it. Find an interpretation that makes it true, thereby showing that the original sentence is not quantificationally true, right? Because if we can find an interpretation that makes the negation false, maybe I should spell that out more clearly. If we can find an interpretation that makes its negation true, then we've shown that the original sentence is such that we could find an interpretation that makes it false. So let me make that clearer. Negate the sentence and construct an interpretation that makes it true. Right? Thereby, which would be equivalent to finding an interpretation that makes the original sentence false. Okay, so where were we? I've stuck a negation sign in front of the whole thing, and now if I push that negation sign through so it shows up on the other side of those two quantifiers, it flips the quantity. Remember, we talked about that back in chapter 7. So the existential turns into a universal, the universal turns into an existential, and out pops the negation sign on the other side. So now we've got the negation of this thing. Let me just write the whole thing out. Rxy and not Ryx. Horseshoe, not Rxx, if and only if not Ryy. Okay, so what we have here following these two quantifiers is the negation of a conditional, right? We have the negation of a conditional. It has that form. Well, we know that the negation of a conditional is equivalent to the conjunction of the antecedent and the negation of the consequent, right? We know that back from sentential logic. Okay, so we're going to exploit that observation, and we're going to now take this, the negation of this conditional, and it becomes, using that equivalence that I just erased, the whole thing now becomes, for all x, there exists a y, and again, we've got this negation of a conditional, so we're going to write down the conjunction of the antecedent, which is Rxy and not Ry, and not Ryx. And the negation of the consequent, so it's not Rxx, if and only if not Ryy. Okay, is that easier to understand? Well, let's take a look at it. It says everything in the universe is such that there's something in the universe that it R's that doesn't R it back. Okay, well this part we have no trouble understanding, right? Everything in the universe is in an unrequited R-ing relationship, right? Everything in the universe is such that there's something that it R's, but that thing does not R it back. But now this has got a whole bunch of negation signs. It's a little bit confusing to get. So I'm taking a look at what's inside this negation sign, namely not Rxx, if and only if not Ryy. And I'm remembering or observing that a sentence of this form, which is basically what we have here, right, is equivalent to that, right? These two sentences are equivalent. The biconditional P if and only if Q is true just when they have the same truth value assignments, and the biconditional if they're negations is going to be true just when they have the same truth value assignments. So observing that, we can just get rid of these two negation signs and we have something that's equivalent. So let's go ahead and do that. I'm going to get rid of that negation sign and that negation sign. Okay, so now we've done a lot of manipulation and we've got it into a form that I think we can parse. But let me just back up and remind us of the big game plan here. We have this sentence. Wow, that didn't mean to. We have this sentence. Our original sentence. So our original project was to show that this sentence is not quantificationally true. But we had a hard time parsing that sentence. To show that it's not quantificationally true means to construct an interpretation that makes it false. Okay, but it's hard to do that because we can't quite get a grip on the sentence. So we realize that if we negate the sentence and we can construct an interpretation that makes the negation true, that would be equivalent to constructing an interpretation that makes the original sentence false. Okay, so we negated it. We stuck a negation sign in front of it. Well, that was not immediately helpful. But then we pushed that negation sign through. We did some more manipulation. We did even a little bit more in manipulation, and we end up with this. This is the negation of that. It's the negation of our original sentence. So now what we want to do is to construct an interpretation that makes this sentence the negation of the original sentence true, thereby showing that the original sentence is not quantificationally true. Okay. So now what we need to do is to parse this sentence, and we were partially there. So what does it say? Everything in the universe is such that there's something that it R's that doesn't R it back. So we have suppose we had two things. So this guy on the left R's this guy on the right, but he doesn't R him back. So we don't have that. We can't, he's in an unrequited R-ing relationship. He R's somebody who does not return his R-ing. Okay, good. And then this part says, well, think about a biconditional, the negation of a biconditional, which is essentially what we have here. This is going to be true just when exactly one of P and Q is true, just exactly when exactly one of RXX or RYY is true. In other words, this is going to be true when exactly one of these guys R's himself, because it can't be that they both do, or that neither one of them does, right? So this part says there's everything in the universe is such that it's in an R-ing relation, in an unrequited R-ing relationship. Okay, we got that. This guy R's this guy, but he's not R'd back by him. And of the two of them, exactly one of them R's himself. So let's have this guy be the self-R-er. Okay, we're on our way. Now what should we do? So now we've got this guy on, on the right. He's in the universe, so he needs to be in an unrequited R-ing relationship. He needs to R somebody who doesn't R him back, so we have to add something. We have to add a guy. So this guy here R's this guy here, but he doesn't R him back. That can't happen, right? So he's in this guy here is in an unrequited R-ing relationship. And of the two of these guys, to make this true, exactly one of them R's himself. Well, it can't be this guy, because that would disturb his situation with his R-er. So it has to be this guy, right? So now this guy is in an unrequited R-ing relationship, and of the two of them, exactly one of them R's himself. Okay, we're getting there. Now we got this guy now, right? We got the guy on the bottom. He's got to be in an unrequited R-ing relationship. That is, he has to R somebody who doesn't R him back. Well, what if we had him R that guy? That would work. But wait a minute. Of the two of them, of the guy that's doing the R-ing and the guy that's R'd, exactly one of them R's himself. But in this picture, they both R themselves. So that can't work. That doesn't work. So we actually have to add another guy. So this is a nice example of, you might be wondering, how do you know how many things to put in a universe? Well, you don't sometimes. You just kind of fool around with it and see. So now, let's add another guy. So this guy on the bottom right, he's the guy who needed to be in an unrequited R-ing relationship. He R's that guy. And of the two of them, exactly one of them R's himself, because we already have this guy R-ing himself. Okay. And now, this guy, since we've added him to the universe, it says that everything in the universe is such that he R's somebody who doesn't R him back. He's got to be in an unrequited R-ing relationship. So let's have him, let's see what happens if we have this guy, our original guy. Okay, he R's the guy up there, but the guy up there doesn't, but we don't have that, right? We can't have that. So this guy is in his unrequited R-ing relationship, and of the two of them, of this guy and this guy, exactly one of them is a self-R-er, but we already have the guy on the top being a self-R-er. And so that works. So it looks like we've got it. We need to have at least 4 things in the universe in order to make this true. But we've got it. Everything in the universe, right? Everything in the universe is such that there's something in the universe such that he R's that something, but that something doesn't R him back. And of the 2 of them, exactly one of them is a self-R-er. So we've got it. We've got it. We've got it. We can construct an interpretation now. Our universe of discourse has 1, 2, 3, and 4. And into the extension of R, we're going to have 1 bears it to 2, but 2 doesn't bear it back to 1. We leave out 2, 1. And of 2 and 1, 1 is our self-R-er. Okay. And now 2 has to bear R to somebody, but it can't be 1, so we added 3. And of the 2 of them, one of them has to be a self-R-er, but it can't be 2, so it's 3. But now 3 has to R somebody, so we added a new guy, 4. And of the 2 of them, of 3 and 4, 3 is the guy who already R's himself. And now 4 R's 1. We leave out 1, 4. We leave out 1, 4. But 1 is already R'ing himself, so we're good. So this interpretation makes this sentence, what color shall I use now? Yellow. Makes this sentence true, but this sentence is the negation of our original sentence, so we know that we have an interpretation that makes the negation true, so we know that not every interpretation is going to make the original one true. So it's not quantificationally true. And that's the end of that example. So I apologize for this, adding another short lecture, but I just couldn't get the pencil to work. I figured out what the issue is. It won't happen again. So this is going to be just another little lecture. Okay, and that concludes Module 10, the optional lectures of Module 10. Okay, bye.